Alright, welcome to lesson 14. Here we're going to begin verifying and applying polynomial identities, including the binomial theorem. So we're actually going to work on this for a couple of days. We want to start off with something pretty basic and essential to looking at any sort of identity. Alright, so go ahead and copy these down and work through them yourself. Pick an odd number between 1 and 10. Starting with that number, write 3 consecutive odd integers. Really note how you did that. 2, given any odd integer n, write 3 consecutive odd integers starting with n. And then 3, the product of 2 consecutive odd integers is 195. Find the two numbers. Alright, so I chose the number 3 here. And you should choose a different number and do this kind of on your own. But I choose the number 3, and when I chose the number 3, the next odd integer is 5, and the one after that is 7. So I could write it as 3, 5, 7. But I also want to think about how I figured that out. So if I started with 3, the next odd integer comes 2 digits after 3. So it would be 3 plus 2. The one after that is another 2 more, so it'll be 3 plus 4. Okay? And so it's important to notice, how did I actually construct those integers? Because if I start with an integer n, and it's an odd integer, the next odd integer is 2 more than n, or n plus 2. And the odd integer that comes after that will be n plus 2 more, which will be n plus 4. So now if I have the product of 2 consecutive odd integers, and that equals 195, then what I'm doing is really writing an equation that looks like this. I have 2 consecutive odd integers. Let's say the first one is n. The one that comes after that will be n plus 2. So the product means I'm multiplying n times n plus 2. And that has to equal 195. Alright, so I want to find the two numbers. Well, I have n squared plus 2n equals 195. Okay, well I have a quadratic. I need to set it equal to 0 and solve. So I subtract 195 from both sides. And here I can use the quadratic formula. So if you use the quadratic formula, you'll end up finding that n is equal to negative 15 or positive 13. Right, well, what you want to consider is that both of these are odd integers, and if I started with one of them, and then I added 2, I would end up with another odd integer. So I started with negative 15, and let's not consider negative 15 first. Let's consider if we started with n equals 13. I would have 13 times 13 plus 2, which would be 15. That's the next odd integer. So it would be 13 times 15, which would be 195. But I could also start with negative 15, because if I had negative 15 times negative 15 plus 2, which would be the next odd integer, which would be negative 13, I would still get a positive 195. So here's the key point. We can represent sequences of consecutive integers by naming the initial integer n and then adding or subtracting from n accordingly. So as an example, and this is I think a very constructive example, let's say I start with an integer n and I want to then go to the next integer. Well, the next integer will be n plus 1. The next integer will be n plus 2. The next integer will be n plus 3, so on and so forth. And this is very important, as you'll see when we look at the binomial theorem, but also in proving identities, that we be able to utilize a variable. Because when we use a variable, we're actually proving that something works no matter what n is. And that's going to be very important. We could also say, let's say you have an integer, and you want to write the number that comes before it. Well, that would be n minus 1, or n then the one after that, n minus 1 minus another 1 would be n minus 2, so on and so forth. You just saw in our discovery problem how we can look at consecutive odd integers, and you can do the same with consecutive even integers. Let's go ahead and take a look at a problem that you're going to finish on your own and we'll discuss in class. So here's the situation. A student thinks she sees a pattern that when taking the difference of the squares of consecutive integers, the answer is always odd. Write the difference of the squares of consecutive integers in terms of any integer n. Then rewrite your expression from part A to verify that the answer is odd. Let's actually talk about A first. Write the difference of the squares of consecutive integers in terms of any integer n. And here you want to look at her work. Okay? So she took the integer 1 and the integer 2 and squared them. Right? Obviously you took the bigger one and subtracted from that the square of the smaller one. Well, how could we represent this in terms of n? So just first think about how you could do that. Consider, of course, that if you start with an integer n, the one that comes after it will be n plus 1. Now notice these are just integers, so you can square them. All right? You can represent them however you'd like. Go ahead and work through A, B, and C. Do not give up here. If you have a particular question, you need to make sure you write it down specifically so that we can tackle it in class. But you should be able to get through A, B, and C. All right? Do your best, and we'll see what you can come up with.